Okay, so for objective for today, I can solve a system of linear equations by graphing. Let's read it together. 1, 2, 3. I can solve a system of linear equations by graphing. So we were already looking at linear equations, and today's concept, all it is they're adding the word systems. So what are systems of linear equations? That's what we're going to be looking at today. So your title for your notes today, just title it Systems of Linear Equations. You write down your objective at the bottom left and get a fair model going, please, for the concept. All right, so here we go. I can solve a system of linear equations by graphing. So what are systems of linear equations? Systems of linear equations are a set of two or more linear equations that have the same variables. A set of two or more linear equations that have the same variable. A set of two or more linear equations that have the same variable. A set of two or more linear equations that have the same variable. A set of two or more linear equations that have the same variable. Tell your neighbor the definition, please. All right, pens down really quick. Let me go over the definition with you and make sure we understand it. Here it goes. It says, system of linear equations is a set of two or more linear equations. That's the first thing it needs to meet. The second thing is that they have the same variables. So let me give you an example. Don't copy this down, just pay attention. Here it goes. Eyes up here, please. Pens down. Eyes to the screen. All right, here it goes. First example. 2, at least 2, yes. Same variables? Yes. Next one. Do we have at least 2? Yes. Same variables? Yes. Next one. Do I have at least 2? Yes. Same variables? Yes. Okay. Copy that, please. All right. So we know what the examples are. Here they are. And according to the definition, we already know the key components. So let me show you some non-examples. Non-examples. Pay attention, please. Here goes the first one. First non-example. Let's see. There it is. If you see it, don't say it out loud. Think about it. Why is this a non-example? Okay. Okay, let me show you a second non-example. A second non-example. Here it goes. There it is. Here's my second non-example. All right, so think about it. We know why these are examples. Why are these non-examples? Think about it. All right, tell your neighbor, why are those non-examples? That's true. So copy these non-examples, and for critical attributes, they need to be at least 2 or more. And they also need to have the same variables. Okay, copy that down, please. Okay, steps. Copy your steps down, please. There's 4 easy steps that we're going to look through in order to solve the system by graphing. Copy those down, please. Step 1, solve for y. In parentheses, you're going to write slope-intercept form. Make sure when you solve for y, I ask you guys to be writing it now in slope-intercept form. Step 2, graph each equation. Step 2, graph each equation. Step 3, identify the point of intersection of the lines. Step 3, identify the point of intersection of the lines. Step 3, identify the point of intersection of the lines. Step 4, check your solution and write a statement. Step 4, check your solution and write a statement. Step 4, check your solution and write your statement. Step 4, check your solution and write a statement. And like I told you, as we progress throughout the year, we're going to be explaining in our statements as to how and what is it that we have as a solution. No longer am I just going to do like x equals this and y equals this or whatever the case. Okay, I need you guys to understand what you're writing. Okay, copy that down, please. Things to circle and underline so you can memorize these steps. Here we go. In red, I want you to circle where it says step 1, solve. Underline for y. Step 2, graph. Underline equation. Step 3, identify, underline point of intersection. Step 4, check solution, write statement. So let's see. Step 1, we solve for y. Do we know how to do that? Yes. And we write it in slope-intercept form. Step 2, graph our equations. Okay. Step 3, identify the point of intersection of the lines. And step 4, check your solution and write a statement. Step 1, solve for y. Step 2, graph your equation. Step 3, identify the point of intersection of the line. Step 4, check your solution and write a statement. Okay, tell your neighbor the steps and have them tell it back to you. All right, so for example 1, we're going to solve and check. And they give us a system y equals 1/3 x minus 3 and 2x plus y equals 4. So what I'm going to do, I'm going to go ahead and walk through this first one, and then I'll just let you do the next one by yourself. Okay? So here we go. Pens down, eyes up here. So step 1 of our note says solve for y. Let's look at the first equation. Is it already solved for y? Yes. Is it in slope-intercept form? Yes. Let's look at the second one. Is this one in solve for y? No. We need to solve for y, and we need to write it in slope-intercept form. So I need to do what? Subtract 2x, subtract 2x. You can write that step down. We got y equals negative 2x plus 4. Step 2. Tell your neighbor what step 2 is, please. Graph the equation. So I'm going to go ahead and graph the first equation in blue. I'm going to use blue for this one. So I'm going to box my y-intercept. What is my y-intercept? Negative 3. So I'm going to start right there. I plot my point, negative 3. And I'm going to use my slope to graph that. My slope tells me to go up 1 step, rise 1, and 3 to the right. So from here I go 1 up, 3 to the right, 1, 2, 3. There it is. I do it again, 1 up, 3 to the right. Okay, and then I'm going to graph my line in blue. And there it is. Okay. So that was the first line. We already graphed it. We're still on step 2. We're still graphing, so I'm going to do the next one in red. I'm going to go ahead and graph this one in red. So for this one, I'm going to box my y-intercept, which is what? Positive 4, and I plot that point, which is right here. And now I'm going to identify my slope. My slope tells me that it's negative 2, but in fraction form is negative 2 over 1. So that means it goes down 2 steps, 1 to the right. 2 steps down, 1 to the right. So from here I go 1, 2, 1 to the right, 1, 2, 1 to the right, 1, 2, 1 to the right, 1, 2, 1 to the right. And I graph my line. Graph our line right there. We're graphing that in red. So let's see. Step 1, solve for y. Did we solve for y? Yes. And did we write it in a slope-intercept form? Yes. Step 2, graph your equation. Did we do that? Yes. Step 3, identify the point of intersection of the lines. Could you see the point of intersection of the lines? Yes. I'm going to circle the spot. So let's circle that spot. In green. Wow. In green, yes. Trash. All right. In green, I'm going to go ahead and circle this spot. I'm going to point an arrow this way. I'm going to write a coordinate. That coordinate for that point, let's see, this is what? 3 of x, negative 2 of y. So I'm going to write 3, negative 2, and I'm going to write right underneath solution. Solution. So just by looking at it, the solution of a system is where both lines intersect. Are we there so far? Okay? So yeah, so for step 4, now we need to do a check and then write a statement. So therefore, let's see. I'm going to rewrite this first equation, but instead of writing x, I'm going to write what? 3, and instead of writing y, I'm going to write what? Negative 2. So check this out. I'm going to rewrite this one right here. Y equals 1/3 x minus 3. And right underneath that, I'm going to substitute these two values. So for x is 3, and for y is negative 2. I'm going to bring everything else down. Open a parenthesis here, and 3. So let's see. What is 1/3 times 3? Very good. 3 over 3. I bring everything else down. And you said that this was a 1. That is correct. So let's see. Negative 2. What is 1 minus 3? Is negative 2 equal to negative 2? Yes. So this made this equation true. So far it works for that one. But we need to check for the second one. I already have my equation here, so I'm just going to substitute the values right underneath. What is my x value? 3. What is my y value? Negative 2. I bring everything else down. The equal, the negative 2, open parentheses, and the plus 4. So let's see. What is 3 times negative 2? Negative 6. I bring everything else down. So therefore, what is negative 6 plus 4? Negative 2 equals negative 2. Is that true? Yes. So does this point satisfy both equations? Yes. Therefore, this is our solution. So at the end, I just need you guys to write a statement. My statement. Here we go. The solution to the system is parentheses 3, negative 2, comma, because. Okay, don't say it out loud. Think about it first. Now I showed you two different ways why it's a solution. I showed you the first one, and I showed you the second one. Think about it. What would you finish your statement with? The solution of the system is 3, negative 2 because, think about it, because of this and because of this. Talk it over with your neighbor. All right, here we go. Let's finish this off. Because it makes both equations true, and it's where they intersect. All right, so this was only example 1. Copy this next one down, example 2. Now you can use the medium ones that are in the back, medium-sized graphs. Just turn it over. Example 2, here we go. Copy this down. It says, once again, solve and check. And here's the system. Y equals x, and y equals negative 2x minus 3. Y equals x, and y equals negative 2x minus 3. Okay? So let's see if you can do this one by yourself, since we already did the first part. The only thing here, in order to graph, we need our y-intercept and our slope. Is that correct? So think about it. What's missing, and how would you write that here? Okay? Think about it. Get started, please. Go. Okay, let's see. As you're finishing up, here we go. For the first one, I saw some of you do this. You're saying this is y equals x. You already have a slope, which is what? 1 over 1. But it's missing the y-intercept, so therefore all we need to do is write plus 0, because it's not there, right? So therefore, let's start graphing this one. Are both of them already solved for y? That's our first step. Yes, so let's graph this one. I'm going to do this one in red. So this one we start at 0. Here it is. And my slope says 1 up, 1 to the right, 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 1 up, 1 to the right. So therefore, that looks something like this. All right, let's do the second one. The second one I'm going to graph in blue. So my y-intercept is -3. That's down here. And my slope is -2 over 1. So that means 2 steps down and 1 to the right. So let's see. 2 down, 1 to the right, 2 down, 1 to the right. And I'll graph my line. You have more space to do more points. That's fine. I don't. I'm just going to graph it from here. So, step 1, did we solve for y? No, it was already solved. Step 2, graph the equation. Step 3, identify the point of intersection of the line. So you circle your spot. And what is the point right there? -1, -1. Hands if you got -1, -1. Okay, and that is our solution. And step 4, we need to check it. So let me rewrite the first equation. Y equals x. So what is my value? -1, -1. Is -1 equal to -1? Yes. Okay. I'm going to rewrite my second equation, but instead of x is -1. Instead of y is -1, I bring everything else down. The equal, the -2, and the -3. So what is -2 times -1? +2. I bring everything else down. Is 2 minus 3, that's -1. Is -1 equal to -1? Yes. So therefore, did it make both equations true? Yes. So all we need to do is write our statement. The solution to the system is -1, -1, because, and then you fill in your blank. Okay? Tell your neighbor what you wrote for the last part of your statement, please. Okay? So, just to verify, if they give you a system and they give you a point to see if it's a solution, what do we need to do? If they ask us to do it without graphing, what do we need to do? What do we do with this point in order to find out if it was a solution? Didn't we substitute into each equation to make sure it was true? Yes, that's the way to find out. So check this out. They're going to give you stuff like this. Pens down, eyes up here. Watch. Look at this one. Tell whether the ordered pair is a solution to the given system. So what do we need to do to find out? Substitute. So check this out. Pens down, eyes up here. We write our equation for both, and all we have to do is substitute the values. If it's true for the first, then we go to the second. If it's true for the second, then it is a solution. Now, some of you are saying, Mr. Q, but I didn't get 0, 0, and 0, 0. It doesn't matter. As long as it's true for that equation. Does that make sense? Okay. Now, what if, let me ask you a question before we move on. What if, when you substitute the first one, it wasn't true? Then that's it. You're done. Okay? Now, hold on. Last one. Sorry. Check this out. Sorry. Yeah. Okay, look at this one really quick. You're going to get a couple of word problems. However, do you see that they give you a system? No, where is it at? They don't, right? What does that mean? That we need to write an equation. Check this out. Look at this one. Video Club A charges $5 per membership and $3 a movie. So The first one, they already charged us $5, so that's plus 5. And how much each movie? So that's 3x. So my second equation is y equals 2x plus 8. Do we know how to graph this? Do we know how to check it? All right, guys, have a good one. Enjoy your homework. Homework is on page 332 to 334. Numbers 1 through 31 odd. Skip. I know. Skip 19 and 21. Have a good one, guys. See you guys tomorrow.